Hello and welcome to all participants from around the world. My name is Arya Peruma, and today we'll be continuing on our Java programming webinar series. And today we'll be doing decision statements. So for this tutoring session, we'll be exploring a lot of exciting topics and delving even further deeper into Java itself and Java programming. So let's get started. So essentially, today, as I mentioned previously, we're going to be learning about decision statements. And basically what we're going to be doing is we're going to be expanding off of previous knowledge we have on decision statements and previous knowledge we have on Java as well. So we're just going to be building upon that today. So essentially, before we actually get started into the coding portion of decision statements, we have to be able to recognize how to relate everything we're doing to a real life situation. So decision statements is basically something that there are a lot of real life examples for as well. And this is really similar to a lot of aspects of coding, not only Java coding, but all aspects of coding in general. So the example one here I've given is if it's sunny, we turn on the AC. So that's kind of a condition. So if it's sunny or if it's a certain temperature or if it's pretty hot, we would want to turn on the AC. Similarly, if there's no food left or if there's kind of lack of food left, we need to buy groceries. And then also similarly, if you are older than 18 or equal to 18, you are eligible to vote. So as you can see, all of these real life situations start with the word if. So it says like if something is happening, then something else will happen. And that's exactly what this is. So essentially, this is what we're going to be establishing today, and this is what we're going to be looking at today as well. So basically, now that we've actually kind of looked a bit deeper into real life scenarios of if statements and kind of I've given a few examples of what an if statement really is in real life context, we're now going to now look at the if statement structure when it comes to code. So on the right over here, I've attached kind of like an image of what the if statement structure looks like in code. So it says if Boolean variable, and then inside the curly brackets, it executes something. So basically, this is the structure of an if statement in Java, and the command inside the curly brace will only execute if the Boolean value is true. So basically, if something is true, and whatever we put inside our brackets, that's really dependent on what we decide to put in the brackets. But if something is true, then our code will print your Boolean value is true. Else, if our variable is false, then it will probably print nothing. And this may seem a bit daunting at first, but we'll definitely be going through a lot of examples today on how this can actually be done. So if you attended last Java tutoring session, we actually learned math arithmetic with Java and how to implement math operators into Java. And we're just going to be continuing that calculator that we built from last session. But no worries if you couldn't make it to the last session. This will build on some of the skills, but today we're not going to be doing much math operations with Java, but rather we're going to be focusing on the statements portion. So don't worry if you missed that. But all we're just basically doing is we're just going to be taking that exercise we did before, and we're just going to be adding if statements to it. So let's go ahead and see how that can be done. So this is the code that we wrote for the last Java tutoring session. And basically, I'm just going to build upon this. So right now we are learning decision statements. So what I'm going to be doing is I'm going to actually add things that relate to decision statements so we can kind of make this calculator better and include decision statements and if statements into this as well. So basically what I'm going to do is inside of this code file, I'm going to be creating a new Boolean parameter, and I'm going to be calling it show progress, and I'm going to be adding it inside the add method. So in a moment, I'll tell everyone what this does, but first I'll just add that in here so everyone can see what that looks like. So as you can see, it says over here, it says static int add, and then it has int num1, int num2. And now I'm just going to add a Boolean called show progress. So another parameter, so Boolean show progress. And all I've done here is just added another parameter. And I've just added that in the add method. So now what we're going to do is we are going to, inside the same add method, we're just going to be working from here. We're going to create an if statement with the Boolean variable called show progress that I just created as a parameter. So basically, what I'm going to do here is I'm going to write I'm going to do it apart from these comments. So I'm just going to enter here. And I'm going to say if show progress and then I'm just going to add a curly brace and then say system dot out dot print, and then in brackets to print this I'm going to say calculating. That's what I want to print. So system dot out dot print calculating. And then basically what this will do is it will run our Boolean variable of show progress. We haven't quite defined if it's true or false yet, but we know it's a Boolean. So depending on if show progress is going to be true or false, it's going to be printing out calculating. And then of course, it's just going to return the result as we have over here. So now essentially what I'm going to be doing is inside the main method, I'm going to be adding a third parameter named true to the existing add method call. So basically that's the existing add method call, and that is essentially over here. So what we're going to do is up here, as you can see, we have int sum equals add, and then we've added two numbers. So what I'm going to do is I'm just going to write true to signify that our Boolean value is true. And I'm just going to add that in there. And then finally, what we're going to be doing is inside our average method, which is over here, inside this average method, what I'm going to be doing is I'm going to be adding a third parameter, which is either true or false to the existing add method call. So we can choose if you want it to be true or false, but I'm just going to make it false just for the sake of example. And basically I'm going to write num1, num2, and false. And now if we save it, let's see what happens. So as you can see, it's saying the average of 10 and 20 is 0. We know that that is not true. That's not really what it should say. But no worries for now. We will establish that later, and I'll actually go through this a bit later as to why that's happening, why this changed. But as for now, that's great. This is what should happen. So we have definitely added if statements. As you can see, I've added an if statement here, and that's cool and all. But however, this was a very simple decision statement, and Java can do a lot more than just putting a simple if statement there and a simple Boolean variable. So I'm just going to go back here. Is basically, I'm going to now go over here. So as I said before, we just added a really simple kind of standard basic if statement. We didn't even have any operators. We didn't even call anything, call any numbers, call any functions. We just have the if statement and our variable inside the round brackets. But not just Java, but all languages actually can do a lot more than this, and especially Java is a very powerful computational language. So what we're going to do is we're going to be able to learn something today called relational operators. And what relational operators will allow us to do is they'll basically allow us to make a little more complex decisions than what we were just doing. So let's see how we can actually do that. So essentially, as you can see, I have attached some images here. So there's kind of three main images here that I want to draw your attention to, which are examples of how relational operators can be used. But at the top, I have, under the heading of relational operators, I have three of some of the major relational operators that we'll be seeing pretty frequently, not only today, but later on if you continue to use Java. So basically, we can use either numbers or numeric values with these operators inside an if statement. So as you can see on the right over here, it says if num1 is greater than num2. And basically, the num1 can either represent a variable or a specific number, and you choose whatever you want to put in there according to the circumstance. So basically, this just signifies that kind of sideways V that's opening to the left. So that's saying if num1 is greater than num2, and this is what it signifies. It signifies greater than. Underneath that, the second picture, we have if num1 is less than 20, and this just means if num1 is less than 20, simply just means that. And then we have underneath that, if num1 is equal to 12, which is just means equal to. So I know there are two equal to signs. This is equal to. But although that may get a bit confusing, this is the relational operator. If you see just one equal to, it's called an assignment operator, which basically means that um, that's not equal to anything. It's just assigning it to the value of this. So if you had, for example, num1 is equal to 1, it doesn't mean num1 is actually equal to 1. It just means num1 is assigned to the variable or assigned to the value 1. So if there are two equal to signs, it actually means that this is actually equal to this. So in this case, num1 is equal to 12. So moving on here, we have a bit more relational operators that I want to draw your attention to. So basically, once again, I've attached an image of the major relational operators. So as you can see, they look kind of similar to the ones we saw before. Some of them do, but all of these have equal signs now. So basically, here are some more operators that we'll be seeing pretty frequently. And just like previously in the previous slide, we can either use numbers or variables inside an if statement when we actually use these relational operators. So essentially over here on the right, I've also attached three pictures as well. And I've also written kind of like what they mean. So we have if num1 is greater than or equal to num2. So if we have a symbol that looks like that, it means greater than or equal to. And if you remember before, it just meant greater. So if I go back here, as you can see, there's no equal to sign. This is just purely greater, but this is greater and equal to. So it's greater and equal to. And then the second picture is the same thing, but it's less than equal to. And the third one, as you can see, it's an exclamation mark and an equal sign. So this means it is not equal to. So before we had equal to, but now we have not equal to. So essentially, when we have this if statement of num1 is exclamation mark and then equal to sign 12, it just means num1 is not equal to 12. And these may be a bit confusing as this not equal to sign actually does have an equal to sign in it, but just really important to consider and remember that when there is the exclamation mark there, um, we need to keep in mind that it means it's not equal to. So now we're going to actually put these into action, put these into some use, and just rather than just talking about them, let's actually go ahead and try to implement these into the code we were just working on. So now what we're going to be doing is we're going to be creating a method that actually compares the given two numbers. So not just adds them or subtracts them or performs some operation on them, we're actually going to compare the numbers. So I'll go back here. All right. So now what's going to happen is essentially inside our class, we're going to be creating a method that is called compare. And what essentially this is going to do is it's going to be a pretty self-explanatory method. And inside this, we're going to be comparing with two integer parameters. So let's go ahead and create that method. So we're going to say static, and I'll scroll down a bit here so we can see that better. So we're going to say static, and we're going to set the type to string. So static string, and let's name this method compare. And then inside compare, and then inside we're going to be putting two integer parameters. So int num1 and int num2. And then those curly brackets to just adhere to Java structure. So I know there is a red line underneath for now, but don't worry about that yet. We'll definitely get to that and fix that later. But for now, we'll just continue. So what we're going to be doing now is, now that we've actually created this string method called compare, inside this method, we're going to actually create an if condition. So first, in order to actually be doing anything inside this specific method, we need to pay attention to the method add. So within that method, we actually added two numbers. So we're just going to kind of follow the same kind of idea. And inside this method, we're going to create an if condition. And we're going to say the if condition is going to be if num1 is greater than num2. So let's see, let's if put some brackets here. So if num1 is greater than num2, and then braces, and then we're going to be adding our return statement. And inside of this if statement, we're going to be adding the return statement, and we're going to be returning a string that tells us that num1 is greater. So we're going to be saying return num1, and then we're going to be concatenating, so concatenating with the plus sign, and then we're going to say is greater than, and then plus num2. And then, of course, we have to put that semicolon at the end. And now that we've established that, we're going to go ahead and we're going to actually implement more with our if statement. So what we're going to do now is inside this method compare, we're going to be adding another if condition, if num2 is greater than num1. So now I'm going to be adding that, and I'm just going to be adding the exact same thing as I just added above, but now instead of num1 is greater than num2, I'm going to just reverse the roles there and say num2 is greater than num1. So we cover all possible test cases. So if num2 is greater than num1. And now what we're going to do is we're going to return num2, then plus concatenation is greater than, and then plus, and then num1. And then of course that's semicolon. And now by doing this, we've actually covered ourselves because we have a possible scenario and a possible thing to return if num1 is greater than num2, but we also have something to return if num2 is greater than num1. So we've covered ourselves pretty good there. So now what we're going to be doing is, now that we've actually have this inside our main method, so inside that main method, we're going to be calling our compare function, and we're going to be saving that result in a variable, and then we're just going to be printing that same variable. So what I'm going to be doing is I'm just going to over here, I'm going to be writing so this is the main method, and inside there I'm just going to say string um, and then we have a variable name, so we're going to be calling let's call this comparison. So I'm just going to call this method comparison. So say string comparison is equal to, so we're going to call the compare method now is equal to compare. And let's compare the numbers. Well, we've been comparing or adding and working with the numbers 10 and 20 a lot. So 10 and 20, and then semicolon, of course. And then I'm going to say system dot out dot print ln, and then we're going to say we're going to print um, comparison, because that's what we defined up here. We defined it as comparison, and then semicolon. And just going to make sure I spelled that right, because it will definitely throw an error if you don't spell it correctly. So comparison. All right, and now as you can see, it's good. So so just remember, if there's even like a slightest spelling error which differs, or any error of that sort, this will not recognize that function name you created, and therefore will not run properly when you actually try to display something. So now that we've actually got this and we've printed our method and we've called our method efficiently, let's go ahead, and I've already saved it, so I'm just going to run that. And just going to say proceed. And as you can see, there is an error, and we're going to be getting to that a bit later, but I just wanted to draw everyone's attention to what it is. So it says exception in thread main java.lang error, and it says unresolved compilation problem, and it has to return a result of type string. And this basically relies in this method we made earlier, and this is because we've changed variable types. So this is a variable type of string, but we haven't really returned it properly. So we're actually going to be getting to that soon. So basically, this is a missing return statement error. And we are actually supposed to get it. Don't worry, we actually are supposed to receive this error right now. And basically, the problem with this is, say that I was comparing two of the same numbers. So say I wasn't comparing um, 20 and 10, but rather I was comparing 10 and 10, which are the same numbers. So if I compare 10 and 10, if both those numbers were the same, none of the given if conditions will work, and therefore the function won't return anything. Because as you can see, I've just given if num1 is greater than num2 and if num2 is greater than num1. And to fix this error, we can definitely use an if-else condition instead. So what we're going to do is we're going to be using if else instead of just if. We're going to be using if else to compare numbers instead of two if conditions. So we have two if conditions here, but now we're just using if else, so we don't get that error that I just showed everyone. So what we're going to do in order to fix this is we're going to say inside the compare method that we created, so basically this one, inside the compare method, we're going to be removing the if condition and we're going to be adding an else condition instead of that. So I'm going to just delete this. So take this out and I'm just going to remove that altogether. And I'm just going to add the else condition. So in order to do this, this is how we should be doing it. So we should say else if num1 is, and then, so I'm just going to be writing it for now to show everyone. But definitely this is something that should be changed a bit later. So I'm just going to say num1 is equal to num2. And then I'm going to say return num1. And then we're just going to return that. So return num1 plus is equal to concatenation there, and then more concatenation to say num2, then semicolon, of course. And now, as you can see, we have kind of this red line, and it's a syntax error, and there is a syntax error here. So basically, I wrote else if num1 is equal to num2. So I just wrote this word equal to, just to show you guys what it should be. So we should be writing equal to, but we shouldn't be writing the word equal to like this. Rather, what we should be doing is we should be going back to here, and I'll show everyone. Um, so when we did talk about relational operators, hopefully you all remember us talking about relational operators just a bit earlier. But when I shared this information with everyone, I kind of went through the different types of operators and their roles. So as you can see, two equal signs denotes something's equal to something. So instead of just writing the words equal to, let's write it in a way that's more Java friendly and say equals equals. And now as you can see, all the red lines disappear and it all seems fine. And there seems to be an extra bracket, so I'll just remove that over here. All right, so now, as you can see, we've covered ourselves even further. So now, if num1 and num2 were the same and we were comparing those when they're the same number, then it will say that it is equal to. And now essentially what we're going to be doing here is we're just going to be separating this off. And I'm just going to be writing else. And then we're just going to basically get this sorted like this. All right. So now that we have this established, what I'm going to now do is I'm going to now move on to our next step. So I'm just going to keep like this for now. And within our next step, what we actually want to do is we want to now try to see if it's even or odd. So I'll give everyone a few moments to just look at this, maybe a minute or so, and just kind of make sure you understand what happened so far. And what we're going to be doing next is we're going to be stepping a bit away from the comparison, but now we're just going to see if the number is even or odd, which is going to be something pretty exciting as well. So yeah, so that's what we're going to be doing after this. And before I do that, what I want to do is I want to kind of go over the bracket structure with everyone. So as you can see, we kind of have a specific structure that we follow. And at first, especially with the Java programming language, this structure can be something that's like a tiny bit daunting because there's so many curly brackets. Like there, as you can see, even this code of 50 lines, um, there is an exorbitant amount of curly braces. And that's just kind of the way Java is. It kind of relies on opening curly braces, closing curly braces. And that's just kind of how the structure and overall kind of syntaxes of Java operates. So it's also important to keep those in mind and kind of pay attention to those as well, because those are like pretty integral parts of being able to kind of program in Java and making sure that there's no kind of errors there. So now we're going to do is there's going to be moving on a bit, and let's see what this is about. So it says local variable num2, and it says this will probably say the same thing. Yeah, local variable num1. And don't worry about this for now. We'll definitely get to this a bit later, like we did to everything else. All right. So hopefully everyone has had a chance to look at this. And now what we're going to be doing is we're going to be creating a method to check if the number is even or odd. So let's go ahead and do that. Okay. All right. So in order to actually be able to do this, what we're going to do is we have to be able to create another new method. And basically this one, let's just keep it kind of consistent with some good variable names. So I'll just name this method even or odd. So I'm going to say, I'm going to be entering a few down, and then I'm going to say static string, or let's not write it outside, but rather in here. So static string, static string, and I'm just going to name this method even or odd. Keeping in mind camel case, which is basically after we start every new word, we kind of start it with an uppercase letter. So basically, we're going to say method even or odd. We're just going to be creating this. And within this even or odd method, we're going to uh, give this method with only one integer parameter and a return type of string, which I've done over here, but one integer parameter. So I'm going to say int num, and I'm just going to call that integer parameter num. So basically, just to reinforce to everyone, this method is purely to calculate if something is um, even or odd. And a few lessons back, or rather even the last session, this was also covered. But this is something called a modulus operator. And I'll comment down a bit here so everyone can see. But basically, a modulus operator is denoted by uh, the percent sign you would get if you do shift 5. So this is the modulus operator, and essentially the modulus operator divides the two given numbers and saves the remainder in a variable. So basically, this will divide two numbers and report the remainder. So essentially, this will just divide two numbers and report the remainder to you. So let's say, for example, we had 7 and 2. So basically, the remainder of 7 divided by 2 is 1. So it won't give you the decimal answer or anything, but it'll just say if you do 7 modulus 2, you'd get 1 because the highest it'll go divide evenly is with 6. So it would just return you with 1. And that's essentially what the modulus operator does. It will just return you the remainder amount, and that's simply it. So this modulus operator is something we're going to be using very, very frequently for our own purposes and creating even or odd and just checking if a number is even or odd, basically. So essentially, inside this even or odd method that I just made, what I'm going to be doing is I'm going to be getting the remainder after dividing the given number with 2. And basically, I'm going to be adding the following if conditions. So one if condition I want to be adding is if the remainder is not equal to 0, we have to return the number as odd. Else, we should return the number as even. So I'll kind of break this down for everyone. So think of what it takes to be an odd or even number. So basically, the only deciding characteristic pretty much of an even number is if it's divisible by 2. So basically, if we divide a number by 2 and it gives us no remainder, then it's surely even because it divides evenly with 2. However, if I divided a number with 2 and I got a remainder, that means it's an odd number because of the fact that it shouldn't have a remainder if it's even, because it should have divided it evenly. So that's how we'll figure this out. And we'll use the modulus operator to figure this out, which is going to be very helpful for us because we're just going to use the operator and we're just going to see if it has a remainder of not or not. So basically, if there's a remainder, then it's odd, else it's even. So I'll write that down. So if there is a remainder, then it is, I'll say then the number is odd, or else the number is, or else it'll just be even. So essentially, that's what we're going to be doing now. So we're going to say int rem, which is just something I'm going to be denoting as a short form. I'm going to be calling this variable rem, which means remainder. And I'm going to say this equals to, which is the assignment operator, is equal to num modulus 2. And then semicolon to adhere to structure. And then we're going to say if rem is not equal to, so we want to say if it's not equal to. So if you remember the operator for not equal to, it was the exclamation and the equal sign. So if it's not equal to 0, then we have to return num and then concatenation. So return this is odd. And then we're going to say is else return num and then concatenation, and then I'm going to say is even. And to put this into perspective, that's just basically what I just said. So if there is a remainder, then it's odd. So basically what I said here, if the remainder is not equal to 0, then we have to return it as odd. Else, if it is equal to 0, if it was equal to 0, then it's even. And that's exactly how we'll kind of differentiate whether it's odd or even. So we have our kind of logic down over here. And now all we have to do is we have to actually be able to print it and display this. So um, to print and display, we're gonna of course go back to our main method over here. And inside the main method, we're gonna call the even or odd method directly inside the print statement. So what I'm gonna do is I'm gonna write system dot out dot print ln, and I'm gonna say even or odd, and we're going to just type a number inside here to check if it's even or odd. So as you can see, I said even or odd, and then I said 10, so even or odd 10. And all this basically means is this basically denotes the number that we're trying to check is even or odd. So we're trying to check the number 10 over here. So basically, what we're going to do is we're going to now look at this and we're going to see if it works. It's just going to test that out. So ignore all of this for now. This is from previous, and ignore the 0 as well. We will definitely get to this later. But as you can see, it says 10 is even. And if I wanted to clean that up a bit better so it doesn't have that lack of space between the word 10 and even, what we can do is we can put a space between the quotations over here to leave a space. And then when we run it, it should have a space, as you can see. So 10 is even. It is indeed even. Now let's go ahead and test this out. And in order to test that out, we're going to see um, up here. Let's pick another number. So let's say 21 now. And as we all know, if we change it to 21, it should say it's odd. Let's see if this actually works. As you can see, it says 21 is odd. And we do have that lack of space again, or that weird space again, weird lack of space again. And because of that, I'm just going to put a space between here and quotations, and then it should be good. So what this means is now you should kind of see space and formatting should look a bit more appealing to us. So as you can see, this works perfectly. It tells us if it's odd or even. And just using the power of kind of the modulus operator, if statements, which was something pretty key, we were able to really easily kind of compute these um, kind of comparisons. And this was something really useful for us. And this is not something that's only useful for just seeing some things even or odd, but it's useful for so many different things. For example, if you're trying to create a game and you're trying to see if the person um, lost a life or not, you have to see if they got hit by 3 apples or something like that. So there's so many more complex areas you could really take this to, and there's a lot of exploring you could also um, do with this as well. So I'll give everyone a few moments to look the even or odd method over, and then we'll move on. And I would like to also show everyone something after this, which is something that is pretty cool and I think everyone will enjoy. Um, so if everyone just wants a moment to look at this and just like see if this makes sense and it's kind of established. Something that would be helpful, and something I would recommend is to memorize the logical operators. And the logical operators were just those 6 operators, those 6 main operators I showed on this slide. And those were pretty integral to what we're doing today, and not just what we're going to be doing today, but just everything within coding in the future. And something important also that I wanted to mention is the fact that um, these specific logical operators, they differ from language to language. So for Java, this is the equals equals is um, the logical operator for equals to, but for all languages, this is not the case. Similarly with the not equal to, and there's many more like that. So it just definitely depends on the individual language, but for Java, these are the appropriate logical operators, and uh, these are definitely what I would recommend using as well. So over here, all I'm going to do is I'm just going to try adding the else statement over here. Um, let's see what I can get. And then basically within this, we're just going to be putting another bracket in. And no worries about the red line for now. We'll definitely get to this later. All right, so hopefully everyone has had kind of the opportunity to look at this and see how this works and how this uh, could be implemented into many other aspects as well. Okay, so that's it, and that's just how simple this is. And as you can see, it was pretty simple and it was pretty easy to grasp. And basically, this is something that we can definitely, as I mentioned previously, implement into many aspects of coding. So what I want to do now is I want to bring everyone back to here. Um, and I want to tell everyone quickly about making a complex decision statement. And what I mean by complex decision statement is something that's kind of goes off of what we just learned right now, but now we're just involving a bit more operators into it, and we're trying to intensify our efforts to create more diversity within our code and to make our code do more cool things. So basically, we're going to be doing something called logical operators. And essentially, as you can see, these operators look a bit different than those other ones. So the other ones are, as you can see, the relational operators, but these ones are going to be logical operators. So logical operators are essentially operators that rather than saying greater than or equal to, or rather than comparing something, it's rather saying a statement. So we can add multiple conditions inside the if condition with these operators, and they're also very useful as well, just as the relational operators were. So as you can see, these are the three primary logical operators that I want to really bring everyone's attention to. So we have the and operator, the or operator, which is two lines, and then the not operator, which is the exclamation mark. And with the end operator, or the and operator, which is denoted by those two and signs, as you can see, we have if num1 is greater than num2 and num1 is less than 50, this code will only run when num1 is greater than 20 and num1 is also simultaneously less than 50. So for example, if we had a number like, let's say 30, 30 would work perfectly. The code will run if our number is 30. But our friend number was like 100, our code would not run because 100 is not greater than 20 and less than 50, but 30 is. So that was just an example. Next, we have the OR operator. So as you can see, the OR operator is denoted by those two straight lines. And if you're having some trouble finding where that is on your keyboard, essentially, it's just the shift sign, shift, and then basically above your enter key, you should see something um, above your enter key. So it's a basically a backslash, and then on the backslash on top of that, we have that straight line that we're looking for. So basically, two of those make the OR operator in Java. And if we have the if condition that if num1 is greater than 20, or num1 is less than 50, the code will run when this is true. So basically, if we had the number of 100, in this case 100 would work because 100 at least meets one of the criteria. It's greater than 20. It's not less than 50, but it is indeed greater than 20, so our code will work. 30 will also work here. So anything greater than 20 or anything less than 50 will work. So uh, so as you can see, there is a difference. This is and, so basically both of them have to be true, but this is or, so it's okay if one of them is not true, as long as one of them is true. And finally, we have something called the not operator. So the not operator is basically what it sounds like. It says this is not this. So for example, we have if num1 is not greater than 20, then code will run. So basically, if it's not greater than 20, so let's see. So if it's like 1, if num1 was equal to 1, um, then the code will be good. But if it's greater than 20, so if num1 was 30, the code will just reject it and it will not run because it does not meet this criteria that the logical operator has set for us. So essentially, this is something that we definitely should be able to keep in mind, and something that I want to, of course, bring everyone's attention to. So essentially, that's all that I had for today. I just wanted to establish these logical operators as well. And we'll definitely be able to look at these more in depth later on in future sessions, and we'll be able to see and explore kind of how these are implemented as well. But these are implemented in similar ways as those relational operators that we just saw, and it has that same idea of um, you can see if a condition meets a certain requirement by seeing if something is um, includes a certain amount or discludes a certain amount. So I can give everyone an example exactly how we just saw there. If we wanted, um, for example, if num1 is greater than num2 and num1 is greater than num3, then this code will run. Then it will execute such function. So if num1 is greater than both of them, that's the only way this will happen, and etc. There are many uses to this, and if, when we actually see this in real life context, this will be really useful for us as well. So that's all I have for today. Thank you so much for joining me today for today's Java tutoring session on the topic of decision statements. I hope everyone enjoyed today's session, was able to learn something cool and something useful and interesting on not just decision statements themselves, but essentially how a concept like this could be applied to real life. Um, I gave some real life examples at the beginning, but there's so many more real life applications to decision statements as well, and I definitely encourage you to explore them and see if you can come up with a small program of your own, like what we did today, just either comparing numbers, trying to uh, find something's odd or even, or there's many other things you can do as well. So, encourage you to explore and try to see if you can figure that out. So essentially, that's basically the gist of decision statements, and that's kind of what is definitely going to be implemented in many scopes of not only Java but other programming languages as well. So once again, thank you all so much for joining me today. Once again, hope you enjoyed, and I definitely hope to see everyone here in a future coding tutoring session as well. And there are many exciting ones coming up, so please do not hesitate to check our website for more information on how to register for those. So with that, thank you so much for attending. I hope everyone has a great weekend and a great day as well. Thank you and bye.